Hey everyone. In today's lesson, we are going to talk about some principles of data collection and go over some techniques for collecting data or sampling techniques. In our previous lesson, we reviewed displaying data. In the next lesson or two, we want to talk about methods to make sure that our data collected represents our population well, and that there's low variability. So first of all, a little motivation. So let's say your principal, Mr. Belding, wants to conduct a school-wide survey on a variety of topics. He's asked you to carry it out. So you are instructed to survey 100 students, and I've given you a breakdown of the number of students by grade. So 100 grade 9s, more grade 10s and 11s, and even more grade 12s and aboves. So how would you select your 100 students? Maybe you want to pause the video and think about that. Would you do something convenient? Or would you do something to get a fair representation of the entire school? Maybe you could think of a couple ways to do it. If you want to pause the video and do that. One way you could do it would just be to, maybe you suggested standing by the cafeteria door and just asking the first 100 students that come by. Maybe visit certain classes and survey those classes till you get your 100 people. Something to think about, and hopefully you thought of this, is in your 100 students, you definitely would want to survey more grade 12s and less grade 9s, because of the school's population, which is 600 people, a sixth of them are grade 9s and a third of them are grade 12s. So it'd be a little unfair to have a quarter of the survey be grade 9s when there's only a sixth of them in the school, right? So we need to discuss certain methods and techniques to survey situations like this, and we'll get at that today. Here we go. First, some definitions. When we're collecting data, we refer to the population as all the individuals in a group being studied. For example, if I was interested in talking about people who have had COVID-19, and I was interested in what their thoughts on their symptoms were or how their experience was, the population of my study would just be people that have had COVID-19. I wouldn't go ask people that did not contract the virus because they wouldn't know, right? So the population is just, you're surveying the group being studied. Or if I was interested in, if you're interested in what a prom theme for your school might be, you're going to ask the grade 12s, maybe grade 11s, but you're not going to go ask the grade 9s about their ideas for prom, because most of them are not going to be going. A sample is a group of items or people being selected from the population. It's the people you're surveying or sampling. Variability, when we're talking about samples, it shows how samples are different from each other. So what you'd like is if you performed a sample several times, so kind of like a similar study where maybe you take 100 out of 600 students, like the Saved by the Bell school there. But if you do this little study or sample over and over again, if the samples are similar to each other, that means you have low variability. The variability is lower. And the more accurately your samples represent the population, because ultimately that's what we want. When we're conducting a survey, when we're collecting data, we want the sample we get to be a good representation of the whole population. Like, that's the goal. Why do sampling? Well, a census, and most people are familiar with this term. A census is when you sample an entire population. It can be very costly and time consuming. I believe, I'm not sure exactly how often Canada does it. It's every 4, maybe 6 years or so. That could be, but it's not done often because it is costly. You got to get every Canadian, and you have to make sure that people in remote areas can access this, and that your data is accurate, and then you've got to analyze this data. So it can be very costly when it's millions and millions of people. But a carefully selected sample, like if you choose your sample well, so that your sample represents your population, then you can get a good idea of people's opinions and what and whatnot just by doing a sample. So often getting a sample is best. It's more efficient, costs less, takes less time, and you can still get a good idea of a good representation of the population. So now we have to talk about some types of sampling. So in these examples here, I've got a little visual of, it's an 8x8 grid. So you can imagine that's a sample of a population of 64 items, students, people, whatever you want to think about. And for each of these sampling techniques, for the first several of them, I'm going to do a visual of what that might look like. So the first type of sampling technique is actually, very simple, and that's where it gets its name from. Simple random sampling. You just randomly choose a specific number of people. So for example, if you put everyone's name of a population into a hat and you drew one or several names, that would be simple random sampling. Each person has an equal chance of being chosen. So for here, if I want a 25% sample, 25% of 64 is 16. So what a simple random sample would look like would just be, I'm just going to put dots here for this, and I'm just trying to be random here, and just show you guys that, simple. How many dots do I have? I lost count. That's 9, 10, 11. So I'm just randomly going about 13, 14, 15, 16. I think I got 16 there. But simple random sampling is just that, just simple random, just randomly select people. It's just like names being in a hat. And then the visual definitely looks like there was no pattern or organization there. It was just a random sample. Our next type of sampling is a systematic random sample. So this is useful when your population, you have access to your population in like an ordered list. So maybe alphabetically or by social insurance number or what have you. So here you put the population in an ordered list and you choose people at regular intervals. So for example, if a doctor was interested in, asking patients about their service or how they, maybe handled this pandemic situation, they might order their patients alphabetically, choose one randomly to where to start, and then select the rest of the sample at regular intervals. So in our case, if I want to select, I'm selecting 16 people, and I have 64. To figure out how many, like what my sampling interval would be, I take the population divided by the sample. So I have 64 altogether. I'm sampling 16, and that's 4. So my sampling interval is 4. So we randomly select a starting point. It doesn't have to be up in the top left, like just randomly pick. And so let's say I randomly pick this person as my starting point. I'll just put a little SP for starting point. And now I select every 4th person. So 1, 2, 3, 4, and I sample this person. And then 1, 2, 3, 4, I select this person. And I just keep going and going and going. And the way this is set up, my grid anyway, I'm going to end up getting everybody in these columns. And then we go back to the start, maybe from the Zs back to the As, and I'm going to get my sample this way. So this is often a great organizational tool to do it. By putting names alphabetically, you're likely not putting people into groups. Like if a doctor sorts his patient list by last name, it's highly unlikely that all of the 80-plus-year-olds are at the top of the list alphabetically, and all the young people are down below. It's more likely they're all just sprinkled in all together. So we can be sure that our sample is probably a good representation of the population. The next sampling technique is called cluster sampling. So in this case, you instead of selecting individual people from the population, you divide the population into groups. Choose some of the groups and sample everyone in that group. So that'd be like if you're getting information from, like, let's say your school population, you might randomly go to several classes and then pick everyone in that class. So here, I'm going to randomly select, and I've got these bolded for you guys. I might just randomly select 4 of these classes because I need 16 people, right? and survey everybody in those. So that's what a cluster sample would look like. And that can be efficient as well. And you can imagine if you're doing this, let's say at school, instead of visiting every class, which can be time consuming, maybe you can randomly pick 4, go just to those 4 and get everybody in there to give you some data. It can save you some time. The next is stratified random sampling. So in this case, we divide the sample into groups with the same proportion as those groups in the population. So a good example of that, a really simple one, is let's say your factory has, we have 1,000 employees, and there's almost double the amount of women than men, 633 women, 367 men. So if you're sampling 100 people, it would be more fair to have your sample have that same proportion of men and women. So 63 women, 37 men. This also relates back to the motivation question, where, you know, if 1/6 of the population are grade 9s, well, then 1/6 of our 100 students, maybe 16 or 17 of our sample should be grade 9s. And if 1/3 of our students are grade 12 and above, then 1/3 of our 100, maybe 33 or so, should be grade 12. So this is called stratified random sampling. And the key word there is proportion. So you think about this as I've got these bolded off like 4 different groups, and we want 25% of each group. So for this group, you know, there's 12 items in this group. 25% of 12 is 3. So I'd randomly select 3 from this group. 25% of 4 equals 1. So randomly pick 1 person from this small group. On the side is another group of 12. Just randomly pick 3 people. And then for this last group of 36, 25% of 36 is 9. And so I'd sample, I want to make sure that 9 people were from this kind of part of the population. So this is a way to be fair. And so another great example of this would be the Saved by the Bell question we started off as motivation with. For the next 3, I'm not exactly going to get a visual. So if you have a very large population, you might want to do several stages. You might want to apply several different sampling techniques at different stages along the way. For example, if the province wanted to collect some data, they might randomly, like let's say the province wanted to collect some data about you guys, about students. It might be impractical for them to get information from every single school. So what they might do is they might randomly select 5 school boards with like a simple random sample. And then in those school boards, they might do a simple random sample of 5 schools. From those 5 schools, maybe do a stratified sample of those to get classes to visit. And then in those classes, do a simple random sample. So you've got a hierarchy like school boards, schools, classes, students, and at every step of the way, you apply some kind of sampling technique. You could also do a convenient sample. So it's kind of as it sounds, you just do what's convenient. So it might be like if you wanted to get data from people at your school, you might just stand by the cafeteria doors and just like and give out surveys or ask people questions and just do what's convenient. So you choose individuals from the population who are easy to access, but it can yield unreliable results since it inadvertently omits large parts of the population. You know, if maybe you hang out in the library at lunch, and if you conveniently just ask people around you in the library, well, then your sample is just those people that, you know, hang out in the library, frequent the library, and you're omitting a large part of the population who might not prefer that and who prefer to do other things with their time. And the sample might be very different from the population. It might not, but it gives that chance. A nice benefit is they're often very inexpensive and cheap to conduct. They don't take a lot of time. And if you're just setting up one space, like you won't have to pay somebody a lot of money to carry this out if it can be done very quickly and conveniently. The last one would be voluntary. You just allow participants to choose whether or not to participate. So maybe at a restaurant, or when you with like they have cards to fill out afterwards, or if you go shopping and at a clothing store and with your receipt say, hey, go, if you want to go online, take the survey, maybe get entered in a chance to win. That's purely voluntary. The thing with these, and we'll talk about bias, I think in our next lesson, with voluntary surveys, usually you only get people who are heavily in favor or heavily against what the survey is about. So for like radio call-in shows, they're discussing a certain topic, like building new subway lines in Toronto or something, or maybe talking about politics. The people that call in are generally have very strong opinions. Somebody who just kind of goes with the flow and might be well informed, but is rational and thinks things through, and they might not call into those to give their opinion. I'm not saying that people who call in are not rational people, but usually people with strong opinions voluntarily do those surveys. All right, so this isn't on your sheet. You just follow along here and just think about what pops into your mind. Little quiz on how we did today. So these first 2 or 3, I believe, I just want you to identify the population that you would have for the study. So if I was interested in finding people's favorite type of baseball glove, Spalding, Rawling, whatever, those are the only 2 I know. What would the population be? So for this one, the population would be people who play baseball. I'm not going to ask, some granny who, doesn't play sports. I'm not going to ask some 2-year-old. I'm not going to ask somebody that, just plays hockey or play basketball. I'm going to ask people that play baseball, right? Consider this question: who do you plan to vote for the next Ontario election? I probably wouldn't ask a high school student. Well, not necessarily. If they're old enough to vote, that's the key idea. I'm going to ask eligible voters, right? I'm not going to ask somebody in Quebec or in the United States or somebody that is ineligible for whatever reason. And for this one, do women prefer to wear ordinary glasses or contact lenses? Well, I'm going to ask women who wear corrective lenses. I'm not going to ask men. I'm not going to ask women who don't wear any of those, because I'm not really concerned about their opinion. I want to know women who have the choice wearing ordinary glasses or lenses, people who wear corrective lenses. So that's a little quiz on, can you identify the population? Let's talk about some sampling techniques. So I'm giving you guys a scenario here, and I'd like you to just think about what type of sampling technique I'm thinking of. So if sorry, that's just my kids. If my population is athletes at my school, Acton District High School, I should select a proportionate amount of athletes from each team. So, if the girls volleyball team is bigger than the cross country team, I should have more people sampled from them. This is an example of, and again, if you want to pause the video and unpause when you've, maybe consulted your notes, that's fine, or you can just follow along. That's stratified random sampling, and the keyword there is proportion. Here's 2. So Sean puts names into a hat and draws them out. I believe we actually use that as an example. That is an example of simple random sampling, where everyone has an equal chance of being chosen. Our third example there, the Ontario government randomly selects 5 high schools in Ontario and then surveys each teacher in those schools. Which of our techniques do you think that one is? That'd be an example of cluster sampling, because we're surveying each teacher in those schools. In the case it's cluster. If you said multi-stage sampling, I could almost buy that. On to the next 1 or 2. So every 5th family in the Acton telephone book is surveyed by phone. And the key word or phrase there is every 5th. That indicates it's a systematic random sample. Right. So for you guys, both my courses, I've got some practice posted for you guys on Brightspace. And I also have a formative quiz on sampling techniques for you guys to try, where I give you a scenario again, and you identify the type of sampling technique. What I've been doing with the quizzes is making them so you can do them an unlimited amount of times, and I believe you get the grade right away, and you can just do it until you get perfect, and I will just take your highest mark. So if it sounds easy to get high quiz marks, they're not weighted very much, but if that sounds easy, it is. It's because it is. So just do your best, but I encourage you to retry them until you get everything. So try those questions, try the formative quiz. Hope you guys have a great day, and we'll see you soon.